As you know, DP system must have the data input from the heading sensor. Among heading sensors, the very popular till now is the traditional gyro compass. There are several different types of heading sensors in use on DP vessels. And as you see, the most common type is the traditional gyro compass. More accurate and reliable but also more costly heading sensors are the ring laser gyro and the fiber optic gyro, based on Sagnac effect. The GPS compass has a precise accuracy but is dependent on the reliable GPS signals. So those are main streams concerned to the heading sensors. The gyro compass finds north by using an electrically powered fast spinning wheel and friction forces in order to exploit the rotation of the Earth. The laser gyro or fiber optic gyro use interference of laser light within a bulk optic ring or a coil of fiber optic cable to detect changes in the orientation and spin and thus to find north. The GPS compass precise heading is derived from the fixed distance dual GPS antenna arrangement to generate heading information. Minimum one heading sensor must be enabled at all times to provide heading information to the DP system for automatic control of heading. Now guys, please concentrate your attention on the next slide. The most important sensor for any DP system is the heading sensor, or traditionally, as I said you, this is a gyro compass. Gyro compass takes part in position calculation for relative position reference equipment, because mostly of them are using the technique of range and bearing to a known fixed position of reflector, transporter and so on. And the system itself of class relative doesn't have any idea about the directions at sea. For right calculation, we need to have the vessel's heading value, which could be measured and provided only from the heading sensor. Pay attention on the next sketch. Here we have two examples of fan beam calculations. In both examples we have the same relative direction and range. The relative direction in both examples is 90 degrees, but when we do the true bearing calculation we have some difference. In example 1 we have true bearing 90 degrees, and in example 2 we have true bearing 180 degrees. But if we have no input from the heading sensor, then mathematical model to those cases will interpret as the one case when relative direction is 0,90 and the range is 100 meters, and will be not able to provide us the right aspect of the vessel at sea. And this is very important for us. So remember please, the most important sensor is the heading sensor for any DP system. For instance purposes, we will use the sensors menu of the KPOS 7, which is available in our training center. And in the menu here we will see next submenus. Sensor group 1, 2, 3. If sensor OK, it means a status signal coming from the sensor itself and make the heading sensor available for selection. Then with the ticks, operator should enable the sensors which are OK. Is the status set by the operator to give the DP system access to use the sensor? The operator will normally enable all available and reliable sensors. There can be a maximum of 3 sensors enabled at one time. When the DP system has the opportunity to accept the input of sensor, operator might give the preference for calculations. When we have more than one sensor, then operator indicates which input from which sensor to give for the mathematical calculation to the P model. So we don't have sensor pooling like in the PRS case. From sensor side, we have the operator preference, and sensor preference is a status set by the operator to tell the DP system which sensor to use. This sensor will be used as the DP system heading reference or any other reference as long as the sensor is reported OK and it is not rejected by any of the tests. The operator should set preference on the most reliable sensor. That's main idea. So you should have enough practical experience and professional judgment to select the right sensor with the preference method for operation in progress or for the expected operation. Remember that, guys, please.